So Will, I was under the assumption that a normal person who's streaming or using OBS virtual camera, they don't need a 2 PC setup. It would run just fine on a single PC, right?
Look, OBS is an incredibly powerful Swiss Army knife for video. It's a really useful piece of software, and I, like you, assumed that the performance wasn't that big a deal. The performance hit wasn't that big.
Yeah.
But I also know that assuming makes an ass out of you. So I tested it to see if it's actually true. And the answers are going to shake you to your very core.
I'm already shaking. So Will, what got you down this path? Because like we said, I think you probably think as well as we do that a single PC setup is all anybody needs right now.
I mean, that's the common wisdom in streamer spaces, enthusiast spaces. The only people who are running 2 PC setups and are like, oh yeah, this is 100% necessary, are like the Counter-Strike pros playing with the settings all the way down to get 600 frames a second, all that stuff. After this testing, I'm going to go tell you, I don't actually think that's true. The performance hit from running OBS on a Windows machine, even just at idle, kind of floored me. It's like buying the next cheaper video card in some cases, sometimes more than that.
Yikes.
And I tested in a bunch of different configurations to see how this actually works.
Okay.
So I ran a couple benchmarks with just nothing running, just standard benchmark procedure, no OBS running in the background. I ran with OBS under load while I'm streaming a video to like the bandwidth test mode of Twitch. So I was streaming a 2K 1440p video to Twitch at the normal maximum bitrate, which is I think 9,500 kilobits per second. And then to kind of see where the load was, whether it was the streaming stuff, where the video encoder handled on the GPU should be relatively lightweight, or if it's more on the OBS compositing side, to see where the performance hit was, I also ran at idle with no streaming, but with the same scene viewing in OBS.
Okay, and what kind of hardware did you test this on?
So I tested this on a variety of CPUs on our standard test beds. Tested on a Ryzen 9600X, a 9800X3D, the one with the V-cache, the gaming chip.
Yeah.
And then I also tested a 9950X3D because I was curious if having more cores was going to actually help performance here. I also tested the best performing Arrow Lake CPU, the 270K Plus.
Or like refresh.
Refresh.
Yeah, okay,
yeah.
and then what about the GPU?
GPU was 5090 across the board.
So these are all fairly high-end chips. I mean, the 9600 I would call like more mid-range, right? That 6-core, 12-thread kind of thing. But I mean, that 5090, you would think, okay, that's going to do a lot of the heavy lifting. So there shouldn't be a performance impact.
There's a lot of video encode horsepower built into that chip. There's a lot of extra CPU cores. I actually ran the 9600 to see if we were getting throttled based on the number of cores we had, if that was impacting it.
Oh, okay.
And I wanted to see if there was more of an impact on that part. And the results were kind of mixed on that. So it's an interesting situation. So the TLDR on all of this is that it seems like when I was doing the stream, I was seeing like a 13 to 14% performance hit across the board.
Across the board, regardless of CPU?
Regardless
across
of CPU.
all four CPUs.
Yeah. So I'm looking at the Intel number. It was 13.69% slower running with the stream. The 9600X was 14.29% slower. The 9800X3D, the gamer's choice, was 13.61% slower. And weirdly, the 9950X3D turned in about the same performance dip.
You're talking about a 13% drop in frames by having OBS open and streaming.
The people who use their old computer to stream their games and do the OBS work look a little bit less crazy right now, if I'm being real. Because 13% is a substantial number. And this isn't an old game. Like this is a game that has been out for a long time.
Yeah.
It's not a particularly stressful thing. The fans don't even really spin up on the computer when you're testing it. I was pretty floored by this result.
And this is a 5090.
It's 5090.
So you would think further down the stack you go,
it's going to get worse.
It's probably going to get worse.
Yeah. So I also wanted to see how much of this was OBS and how much of it was the streaming, right?
True.
Because we talk a lot about the video encoders built into modern GPUs and CPUs as handling the heavy lifting of the H.264 video encoder.
Yeah, that shouldn't really affect the game performance because the video encoders, those are separate.
So I ran the same benchmarks with the same scene visible in OBS, the same compositing happening on the OBS side, but I turned off the stream. I just stopped the stream. It was easy. I pressed stop stream and then ran the benchmark 3 more times.
Okay, and?
And the results were, the cluster was a little bit wider in the percent differences. The results were equally consistent from run to run. Compared to OBS not running, just having OBS idling in the background was still good for at least a 10% dip.
Whoa, that just means that's just OBS doing its thing.
Yeah.
And also the scene that you created was not a complicated scene.
It was not what I would call a streamer-ready stream. It didn't have any kind of browser overlays with notifications. In this case, for these numbers, it was just the game display. Now, the game, there's multiple ways to capture games in Windows with OBS.
Okay.
There's display capture, which is where you say, I just want to take everything that's on display one.
Just the screen.
And the whole thing, like the taskbar, any kind of other windows that pop up, your password manager, it'll do it all. You probably don't use that if you stream to Twitch or YouTube or whatever. There's also game capture, which is a little bit more performant by reputation.
Okay.
I did do some game, so I used the display capture numbers for these runs just because it's easier and more. It was easier to have more consistent and less chance of screwing up.
More repeatable.
Yeah. The game capture mode was a little bit more performant than the display capture, but not. It wasn't like 5%. It was like 1.5% at most.
These numbers are wild, dude.
These numbers are wild.
Like,
I ran this multiple times because I was like, this is blowing my mind.
What numbers did you expect?
I was expecting under 5%.
Yeah.
Like I was expecting 3 to 5% total for the entire run.
Yeah, so you ran another game though. So
Yeah.
maybe it's just Shadow of the Tomb Raider.
Yeah, Shadow of the Tomb Raider is a pretty CPU bound at this point. Like I said, it's an older game. I went with a slightly less old game. And I'll be honest, when I was picking the benchmarks to run here, I skewed in favor of things that don't take 10 minutes to run per loop because I didn't want to be doing this over 3 days. Cyberpunk, running ray tracing, overdrive, the full path tracing mode.
So this is I mean, it hits the CPU hard, but it's also very GPU bound.
Makes the GPU fan spin up.
Yeah.
I ran it, again, 4K DLSS balance using the transformer model, no frame gen.
Okay.
And this is, again, capturing with the display capture mode. Streaming, the streaming modes are 1440p, streamed to Twitch, no resampling at 9.5 megabits, 9,500 kilobits per second.
Okay.
Similar numbers, similar deltas. So I saw ironically on this one, the 9600X was the least dip. Almost the least dip.
Yeah.
It was a 9.92% decrease when it was streaming.
Yeah.
The 9950X3D was 10.68, and then the 9800X3D and the 270K were both about 11% decrease under the streaming load.
So this is with OBS streaming, and this is a couple percentage points difference from Shadow of the Tomb Raider.
It's a little bit of a less. It's a less bad decline than Shadow of the Tomb Raider.
But that's still like 10%.
It's a much more GPU-bound game, too.
Yeah. So that is correct. Okay,
but 10%, like, I will do bad things to get 10% more performance out of my computer.
Right.
Just to be clear. Like awful, terrible things. Okay. We don't want to talk about it, okay? We can't get into it.
We can't get into it.
No, we can't talk about the things that we've done. Adam, you think I've done bad things? Adam's done even worse. Yeah.
Okay. Well, what about just sitting there at idle and not streaming out?
So that was between 6 and 7.5%.
Okay, so it's still less than Shadow of the Tomb Raider. And the delta between the CPUs is still within like 1.5 percentage point. 1%. Yeah. Okay, so. Listen, I think there's a couple things here. The first one I guess that boggles my mind is that from a 6-core 12-thread all the way up to a 24-thread machine.
Yeah.
Like we're talking about within
doesn't matter.
Points.
Yeah.
Yeah. I mean, so at that point, like it matters the game.
Yeah.
Like it doesn't matter necessarily OBS, right?
My working theory, again, I'd have to do more testing to confirm, but my working theory is that the more GPU bound your game is, the less of a hit you're going to see. Mm-hmm. But when you're talking about games that are super performant, like Shadow of the Tomb Raider is probably running at 200 frames a second in this instance, you're going to see more delta because the performance impact is hitting the bottlenecks more than and that bottleneck is having an oversized impact on your overall performance. Now, does it matter when you're playing Shadow of the Tomb Raider? Probably not. But if you're playing Arc Raiders or Marathon or PUBG or Fortnite or something competitive, a 10% performance hit is pretty substantial.
Well, but then I mean, and this is on some of the best hardware you can buy right now. So the other part of it is like, oh, okay, man, for somebody who has
if you're on a 5800
X3D with a 3070 or something like that, how does that look? Man.
And if this is my hunch is this might be memory bandwidth because a lot of the places that this is happening is either PCI Express bus speed between the GPU and the system memory, which is going to be memory bandwidth dependent. I wonder if, like, running this on an AM4 board that only has DDR4 and you're running at 3,600 megatransfers per second instead of 6,000, you're going to see an even bigger hit.
And you were using NVEnc to...
This is using NVEnc for the video encoder.
Yeah, so I also then wonder the AMD side of it as well, if that changes it. I mean, there's always so much more testing you can do, but man.
My assumption is that here's the thing. The idle number without the encoder running was enough of a performance hit that I was concerned. When you add the streaming load on top of that, it gets even worse, right? And
I mean, once again, the scene is not that complicated.
No,
like this literally is just the game capture.
There's none of the browser compositing. There's no transparency. There's no like background removal or any of that. Like you can do really crazy and complicated stuff in OBS these days, and this is none of that.
That's crazy.
I was really curious. I was really surprised by this outcome.
I mean, does this change the way that you would recommend people set up streaming? What should people take away from this?
So when you're starting out as a streamer, my advice is don't spend any money until you start making money, right? So
that makes sense.
Because a million people, like the urge to build gear and collect gear is always strong amongst everybody. You know this, I know this, they know this. You don't want to go out and you don't need to spend $1,000 on a microphone, and you don't need to spend a bunch of audio gear and camera gear and stuff like that if you're running a stream that 3 people are watching and one of them's your mom, right? When you get to the point that you get your first check, then invest that in your setup, right? And that's the time to think about that. When you upgrade your PC the first time, I used to tell people not to bother to set up the 2 PC stream rig because it's a pain in the butt. I don't know that that's true anymore, especially if they're playing competitive games. If you're playing single player stuff, probably still fine. But if you're playing a lot of competitive multiplayer games, then consider maybe not running OBS on that machine, on that local machine. And it definitely means that when I launch a game now, I make sure OBS is closed.
Yeah. Well, are you shook? Are you as shooken as us?
I'm pretty shook.
Yeah, these numbers are pretty. I did not expect. I expected you to come in here and be like, hey, you know what? I ran all the tests and it's like 3%, within margin of error.
Literally, I started doing this testing because I had a machine set up to do this testing on a different project entirely, and I was like, you know what? I could do that OBS testing that we've talked about for a while. We can just say on the podcast, hey, OBS, it's pretty good.
Yeah. But
nope. Sorry, OBS. Wow. I love OBS. Just to be clear, OBS, I still heart you.
Free and open source. We love it. Yeah. Man. Okay. Well, that's crazy. Let us know your setup. Because I mean, are you willing to switch to having a 2 PC setup now? Seeing some of these numbers, did you do any testing? Are you seeing any similar drops?
I would love to know what this looks like on other machines, especially older machines. Like if you have a DDR4 system, I would love to know. If you're running the Intel GOAT processor 14900K, let me know how it goes.
Yeah. And congratulations, it's still working.
Yeah, you won the Silicon Lottery.
Yeah. Boom. Good job on you.
But yeah, like this is the kind of thing that I love to test because it's always fun to see, like whether it ended up being fine or we found a big performance hit. Who knows? Maybe there's some bug that nobody's discovered in OBS and this is an easy fix. And they'll be like, oh God, this is embarrassing. It's fixed in the next version. I don't know.
Yeah.
But I'm shook.
Either way, myth busted. Great. Good job.
That's somebody else's trademark.
Okay. Well, anyway, thank you for doing the testing.
Always a pleasure.
I appreciate it. And thanks everybody for watching. Subscribe. Watch the next video.
It's probably good.
Can't promise anything.